Our aspirin experiment is our stoichiometry experiment. So we have a basic chemical reaction where we had salicylic acid, and I abbreviate that SA, combining with acetic anhydride to make aspirin and acetic acid. Now, we didn't do anything with the acetic acid, so I'm going to ignore that. Notice that this is a 1, all the coefficients are 1, so 1 to 1 to 1 ratio. And also know that we added phosphoric acid. It was our catalyst. So I could put that over the arrow. Okay. And the thing that was different is that instead of having a mass for everything, on this one I had a mass for my salicylic acid. For the acetic anhydride, you have a volume. And because of that, you need its density, which will be given to you. Okay, so we have our density, we have the amount of our salicylic acid, the amount of acetic anhydride. The 3 drops does not matter. Phosphoric acid is our catalyst. We heated it. The temperature and the time we don't need to worry about. Those aren't numbers we will use. Okay, and then we crystallized and filtered and dried the aspirin. Okay, and we have a final mass. So one thing you should know is that at the end, that mass of aspirin, this is the actual yield. So let's start going through these questions. How many moles of salicylic acid were added to the reaction mixture? Well, I was given the amount of salicylic acid as 3.01 grams. And to get to moles, I'm just going to use the molar mass of salicylic acid. You may have to calculate it. It may be given to you. Because you're going to be rounding in multiple places, you might, or doing different steps, you may keep extra digits, but know that if you write the answer, or you choose the answer at this point, it really only has 3 sig figs. Okay. How many moles of acetic anhydride were used? And this is the trickier one. You use the volume of acetic anhydride, and to get to moles you have to go to grams first, and this is where we use that density. And then from grams we go to moles, and this is once again a molar mass. Let's just mark both of these. That one's molar mass of salicylic acid, molar mass for that step. Okay, so I have the moles of each reactant now. And so the next thing is think about how many moles each of those could produce if they completely reacted. And the key here is that it's a 1 to 1 to 1 ratio. So if all the salicylic acid reacted, I could get this 0.0218 moles of aspirin. If all of this did react, I could get this number, and I'm going to round it as an answer, but you can carry extra digits in your calculator. Okay, so that's predicting the possible yields, and basically you look at those two and compare them, and the smaller is the correct theoretical yield. And so this one's larger. So this one is my theoretical yield. Okay, and I just brought those numbers down over here. And so what is the correct theoretical yield? Again, this is where I looked at these two, and the smaller number is the correct yield in moles. Watch for that, because sometimes we ask for it in grams and sometimes we ask for it in moles. This is it in moles. Ask what the limiting reagent is. A reagent is always a reactant. It's the reactant that predicts the lower amount. And so if we go back up here, what I'm talking about, when I compared these two and I decided which one was a lower number, if I go back and look at what reactant that was, it was the salicylic acid that predicted that amount. So my answer here is salicylic acid is my limiting reagent. And then if I want to get my theoretical yield in grams, I'm going to take it in moles. I may have more digits in my calculator. It doesn't end up mattering on our lab midterm because it's a multiple choice. So if your digits vary just a little bit, like on the last one on the right, you can choose the one that's closer. It won't be so close that you can't tell. So to do this, I need to use the molar mass. This is the molar mass of aspirin. If it were an answer, I need to round it to sig figs. Okay, and then what is the percent yield? So percent yield is always actual divided by theoretical times 100. And the actual is what, when you weighed your aspirin at the end of the experiment, that was the actual yield. So for a test or quiz or whatever, this has to be given, a given number. And I showed it to you a little bit ago. So we had 1.52 grams in the problem statement, and then divided by this theoretical yield. Again, I had more digits in my calculator. Okay, and that's my percent yield. Let's do another example. And on this example, I wanted to show you because the number, you don't always have grams. You could just start with moles. And on this one, I will say that we have to assume that complete combustion, that there's plenty of oxygen available, but we'll see. Let me go through how this works. Okay, so what you do is you take your balanced chemical equation. I have 9 moles of this and 5 moles of O2. and I'm asked for the theoretical yield of CO2. Okay, so what you do is you take each reactant and predict how much product it could make. And I'm interested in the CO2. And for the numbers here, I use the coefficients. On the aspirin, the coefficients were all 1, so we kind of skipped this step. We just talked about it. But on this one, I need to use these numbers in front and those numbers. So on this one, it's 1 to 1. Again, this is using the coefficients. And it didn't ask if I needed this in grams. I would use a molar mass, but I'm just going to leave it in moles. Have to make this cancel. That's why it's down there. And again, the coefficients this time are a 2 for the oxygen there, and a 1 there. Okay, and again, I compare the two predictions. And the lower number is the correct theoretical yield. So it's this one. And in this case, if I wanted to say the limiting reagent, again, it's the reactant that predicted the lower yield. So I would come back over here and it's the O2.